Hi everyone, my name's Mharlyn, and for today, I will be recording my laboratory exercise number 7 for IT 211 Data Communications and Networking 1 CISCO 1. The title for this activity is IP addressing exercise. All of the end devices or computing device have the Internet Protocol address or IP address. It is the unique identification of all computing devices such as laptops, personal computers, printers, servers, etc. Since the computer understands only 1 or 0, it is important to know the language of the computer. It should be converted to a language that will be understandable by humans. It is called the decimal number. Binary number is converted to decimal form. In these exercises, it is very important to know the conversion of decimal to binary, binary to decimal, or even converting to octal and hexadecimal. The objectives of this exercise is to convert binary numbers to decimal and vice versa, to determine the importance of IP addressing in networking system and its subnet mask. Identify the 3 types of addresses: network, broadcast, and host address. Identify the network portion and the host portion of an IP address. Procedure 1. Convert the following IP addresses to binary numbers. Letter A, 201.17.29.4. Letter B, 192.168.1.1. Letter C, 172.0.0.0. First off, you have to find out the binary number of separation, like for the first 201.17.29.4. We have to find out the separate binary for all numbers like 201, 17, 29, and 4. In the first part, here, we have to divide 201 with 2, so we can get 100, and the 1 remain, which we are going to write in the middle of this sheet. In this part, what I did was I have divided 201 with 2, 201 divided by 2, so we get here 1. Actually, it's 101, but I have removed the 1 there and have retained the 100 on the left side, and then placed the 1 on the right side of this table. In the second part, we have placed here 0 because nothing is remained in the number 50. So we have to do the same thing like what we did here in 201, 150, till we get 0 or 1 continuously. In this part, as you can see, both of them are equally 1 because we have finished and the value has come to 1. We have to do this one first so we can find out what is the binary for the IP address. So once we're done with this table, we will first start with the end value and then all the number in reverse order. So we can get 11001001 binary for our decimal value 201. If the number is not in 8-digit, we can convert it in 8-digit. Like for 4 binary is simple, like 100. So for converting in 8-digit, we must add like 50 or so before this. So it can be like 0000, 100, and so on. So there you go. For procedure number 1, we have successfully converted the following IP addresses to binary numbers. For the first one, we have 201.17.29.4. On the right side, we have placed there the binary numbers for each 201, 17, 29, and 4. For the letter B, 192.168.1.1, we have placed the binary number on the right side, as well as for the 172.0.0.0. We have answered the binary numbers on the right side too. Since the letter C corresponds to 0 IP address, it has given us an answer of 0. As we mentioned a while ago, we have to make sure that the numbers are composed of 8 digits. So if it's not 8, or if it's giving us 4 or something like the last one in here, last example right here, we have to add zeros to make it 8 digits. The zero should be added before the result of our IP addresses binary numbers. Procedure number 2, convert the given to decimal number. Convert this given binary to decimal number. In this example, in this laboratory, I have used the Excel sheet to convert the binary to decimal number. This one that I am highlighting right here is the binary number which are given in our laboratory procedure. And I have placed here these digits above the binary numbers as a mark that corresponds to the binary numbers down here below. So the rule for converting a binary number to decimal number, starting numbering the position of the numbers from the very extreme right end of the number with 0. For example, in this example, the last digit should be given 0th position, and then like the second digit from the last should be given first position, and the third should be given from the last should be given second position, and so on. So your first digit gets 31st position if we did it just right, or if we did it in the assigned position order. So in this activity, so the last number of the binary digit started with 0, followed by 1, 2, 3, 4, 5, 6, 7, up to 31st. And we started at the farthest right side of the binary. So now the formula is that we need to multiply every number by 2 in the assigned position. And the generic formula is 2 raised to whatever corresponding number is that times the number. So in this given activity, since the last digit is assigned the 0 position and the digit itself is 0, we are going to compute 2 to the 0 times 0. First digit is assigned 31st position, and hence the value computed is 2 to 31st times 1. Then after that, if we add all the computed values together, we are going to get the required number in decimal form. So there you go. This 347334920 is our decimal converted from binary numbers. As instructed from this lesson, we have to do it manually and just use calculator for checking, but I am so sorry to say I have used the Excel sheet because you know, for obvious reason, I am working and I have other stuff to do, and it will take a whole lot of my time, like calculating and doing it one by one, each and every step. So I just use the Excel sheet for this, so it will make the procedure faster for me as well. So there you go. I hope this is the correct answer, 347334920. So to explain what I did right here, because I'm very sure that I have fast forwarded the previous video. So I have written the binary numbers on top of the Excel sheet. As you can see on this video, the binary are these digits located on top of my Excel sheet. So these are the corresponding numbers for the binary. So from, as I've explained earlier, from 0 to 31st. So we always have a base 2. What I did was I have placed it right here, 1 times 2, and then this is the corresponding digits, 31st. There you go. So on and so forth until the end of this line. So I did the same thing one by one up to the end of the line. I can show you that. There you go. And then what I did next was so we took the result of 2 to 31. So this is here, this 2147483648, and then times it to 1. So this is gonna be the same answer. I did the same thing with 30. 2 to 30 is 1073741824 times 1 is the same thing, 1073741824. I did the same thing with a 29. 2 to the 29 53 is 536870912 times 0 is 0. I did the same thing with 2 to the 28. It's 268435456 times 0 is equal to 0. I did the same thing from 31st all the way down to the 0 of the binary digit. Now, what I did was, since, as you can see, I have highlighted the results which corresponds to the digits of 1. Okay, so you might have observed that some powers are missing right there. I didn't highlight them. The positions in which we have 0 as a digit has been completely omitted as the computed value, because it wouldn't anyway be 0 and it has no significance in overall value calculation. So I highlighted each and every one's digits of this binary result, and then I have added them. So the result is this down here below, 347334928 So all of these highlighted in yellow are the ones remaining in one digits each, because you know it's just a waste of time if you're going to calculate and include all the zeros right there, because it's not going to give us any value anyway. So just calculate the ones with has values in there, like the number 31, 30, 27, 26, 25, 24, and so on. Question number 3. They have given us the network address 192.168.1.1. What is the network address in binary? So there you go for number 3. The binary address of 192.168.1 and 1 is located on the right side of the screen, written under the binary number section. This answer is also attached as a PDF file in our Word format to be submitted in this laboratory number 7. Now we can proceed answering the questions for this laboratory number 7. Question number 1, why do we need to convert the decimal value to binary numbers? Computers on the lowest level read and manipulate binary representations. But this does not mean that they can't be programmed to manipulate octal, hex, or even any other number-based system. The choice of hexadecimal representation is taken because of human readability and ease of conversion. Question number 2, why all computing devices have an IP address? Every web-capable device needs an IP or Internet Protocol address to enable it to access the Internet. Without an IP address, computers wouldn't be able to communicate with each other. Every Internet-capable device, from your computer to your smartphone, has its own unique identifying IP address. Is it possible to have a similar IP address among n devices? Two computers cannot have same address when they are using IPs from public address space if they are connected to the internet. However, if those two networks are not connected to the internet, they can use the same public IPs. Yes, any two computers can have same IP address on different network. Question number 3. What is the importance of the subnet mask? Subnet masks are critical to communications on an IP network. Network devices uses the IP address targets and define net mask to determine if the network the host is on is a local subnet or a remote network. This is important because devices act differently depending on the result. Question number 4. What can we conclude from this activity? This lesson has provided us the basic information that we need in order to configure the router for routing IP, and how addresses are broken down, and how subnetting works. We also learned how to assign each interface on the router an IP address with a unique subnet. Thank you so much once again for being with me on my laboratory number 7. IT 211 Data Communications and Networking 1, CISCO 1. I really appreciate your time and effort getting through my laboratory and checking them one by one. Once again, thank you so much, and please be with me on the next chapter of this course.